You're welcome back to my YouTube channel, and in this video we are going to be talking about homogeneous equations, that is equations that can be solvable through the homogeneous equation method. Now, how do we know if an equation can be solvable through the homogeneous equation method? First of all, the thing is going to be in the function of f of x and y all together would be equal to another function of x and y altogether. So now in this particular case, we cannot just have directly a equation solvable by separation of variable, even though we need to keep this in mind that all would lead back to equation separation of variable. That is where all would is going to lead to. So we need to understand our separation of variable very well, so that we understand that the homogeneous equations are going to be we are going to break it down to a form whereby we can be able to solve it using separation of variable, something like that. So now let's say we have an homogeneous equation whereby x and y is mixed together. We just have to impute the value of y is equals to vx, and that equation is solvable. Now let's say one of the form in which I am able to identify an homogeneous equation, because an homogeneous equation you can find it similar to a linear equation and other stuff like that, but one of the ways that is famous for that is um my personal way of identifying the homogeneous equation or an homogeneous function is when the function can be broken down into a function of y over x. I'm going to show you an example of what I'm saying right now. Now we have a question here. We have 2xy plus x squared times the y dx is equals to 3y plus 2xy. And we see x and y is mixed together, y square is here, x and y is mixed together, x square is here. So if I want to break this down, I want to make the y dx to be on one side, while every single x and y value will be on the other side. For now, so we have the y dx is equal to 3y square plus 2xy divided by, when we bring this there, we have 2xy plus x squared. Now, this is particular equation here that we need to solve. So we just input y equals to vx, and it's going to be solvable. But there are questions like this that cannot be solvable even if you use homogeneous equations. So how do you identify if something like this is an homogeneous equation? Now, as I said, this is my own personal method of breaking it down. First of all, an homogeneous equation can always be put, an homogeneous function can always be put in the as a function of y over x. That is, I can take the biggest value for x here, like I can pick the biggest value for y here, and find for the x of that value and divide everything through by it. So I divide multiply everything here by x square over x square. I multiply everything here too by x square over x square. That is just to confirm if it is an homogeneous equation. So now here I'm going to be having 3y square over x square here. Then we're going to be having here plus 2xy over x square. So we're going to be having the other x square outside, which is the multiplication. So now here, if we do 1x is divided by x here, we are going to notice that here there is a consistent value here. So here we are having 3 into y over x all square plus 2 into y over x here. We can bring our x square value here, and even in the one that is under, if we do the same thing, we are going to eventually have 2 into y over x, and here we are going to be having 1. We bring our x square here and we can cancel each other right there. So we see that now this is a value of y over x, y over x, y over x, not y square over x, not y over x square. We have y over x all square, y over x, y over x. Now this is how we know that this is an homogeneous function, and if we impute this value here, it is going to help us to be able to solve this equation very well. So that is how you know it is an. Now let's go back to our question. Let's go back to our question here. So first of all, we are going to be imputing y is equals to v over x, right? And we are going to be imputing y equals to v v times x. Now, if we are imputing y equals to v times x, what will happen to dy dx? So now, if we differentiate both sides, v is a function of x and x is also different from v. So we are going to be having dy dx is equals to, now if we are going to use product rule, if you know what product rule that is, if you have a function of, you want to differentiate a function of u and v, is going to be equals to du v du plus u dv, which is this product rule right here. That's what we are going to do here. So we pick this as our u and this as our v. So now we have v here multiplied by, if we differentiate x, we are going to get 1 that is multiplied by 1. So we can just ignore the value of 1 that is there, and we have plus our x here. If we differentiate v, we are going to have 1, but it's going to be dv dx at the back, since we are differentiating with respect to v and with respect to x. So it's only the one where you differentiated x that are not going to find. So now dy dx is going to be equals to this value now. This here should be very, you should keep it very important. We are going to impute this and impute this into this particular equation here in order for us to be able to solve it. Now let's go. So dy dx is equals to this. We have v plus x times dv dx is equals to, now y is equals to vx. So we have into bracket 3 v square x square, and we have plus 2x, y is equals to vx. So we have v times another x here. So we can just do x times x, and we're going to be having 2x square v. So let's remove the bracket for now. Yeah. Over 2xy, we have 2 times x. Our y is equals to vx, x times x here, that is x squared. So we have plus our x squared is just going to remain there. So now what we see, that something is common both in denominator and in denominator. We have x squared here, x squared here, x squared here, x squared here. So we can just bring that x squared out. We have v plus x dv dx is equals to x squared into bracket 3v squared plus 2v divided by, we have our x squared from the bottom, we have 2v plus 1. X squared cancel x squared. And now since we have this as this, we can bring v from this side to this side. So therefore we are going to be having v here. If v comes to the other side, it's going to become minus v. It's going to become minus v. So now let us continue. We are going to be having x dv dx is equal to, our x squared has cancelled here. We have 3v squared plus 2v. Now what we want to do here, we want to find for the LCM. We have v over 1 and we have 2v plus 1. So the LCM here is going to be 2v plus 1, which is under here. So 2, if we multiply by this, we are going to be having minus 2v squared, and we have minus v. So now this is going to be our answer here. So this is x dv dx is equals to 3v squared minus 2v squared. We have v squared, 2v minus v, we have plus v, and we have divided by 2v plus 1. So now that we have already seen this, if we notice, if you were with me during the separation of variable, notice that we can be able to put the v in one place and the x in the other place. So we bring all the values of x to this side, all the values of v to this side. So if I'm going to bring all the values of v to this side, it is going to become 2v plus 1 divided by v square plus v. Then we have our dv. That is, if we bring it to this side, you know this is going to turn upside down when it's coming here. And here we are going to be having is equals to dx over x. What do we do when we see our separation of variable? We add our integration to both sides. We add our integrations to both sides. So now we integrate this. Now, how do we integrate something like this? First of all, if you are very observant, you understand that what is below is what is above is the differentiation of what is below. That means in this particular case, we are having f prime of x over f of x, that is the integral of this. And if you are very good at integration, you know that this right here is equals to ln f of x, ln f of x, that is this. This is what it looks like. If you differentiate this, you are going to get this. That's what you are going to get. But let me just not go through the shorter way, and let me try to like explain why this is equals to this. So now we are going to be having our, that is for this, we are going to be making our u to be equal to v square plus v. So therefore our du is equals to 2v plus 1, and we have dv with respect to v. So if we are going to be making our um, dv the subject of the formula here, we have our dv is equal to du over 2v plus 1 right here. And if we impute it inside this equation, it's going to become an integral of 2v plus 1 over our v square plus v has become u over u. Then we have times our dv is du over 2v plus 1. 2v plus 1 cancel 2v plus 1, and we will know what that is. So this is equals to the integral of dx over x. If we continue our integration here, this is integration of du over u is equals to integration of dx over x, and this here is going to lead to ln u is equals to ln x plus ln c right here. So since we have had this, I can bring back my value for u, which is v square plus v. I can decide to finish it first. So now, if we have something like this, we can bring our u and x together, or I can decide to just leave it like that. Yeah, I can decide to just leave it like that, and I can decide to bring u and x together. But let me just bring it to this other side. We are going to be having ln u minus ln x is equals to ln c. And we know that ln u minus ln x is the same thing as ln u over x. So if we just add our exponential sign to both sides, e cancel ln and e cancel ln. So now what is our u over x? Our u is equals to v square plus v. We have v square plus v over x, which is under here, is equals to our constant c. And now what is our v again? Since our y is equals to vx, therefore our v is equals to y over x. So we are going to be having y over x, y square over x square plus y over x all over x, which is under here. We have equals to equal to c. So the x here is going to, we have x here, will cancel x here, and it will cancel 1x here. So we are going to be having our final answer. We are going to be having our final answer as equal to y square over x plus y is equals to c. Let me bring it somewhere up here. We have y squared over x plus y is equals to c. So now this is going to be our final answer from here. So now that is how we solve an equation that is solvable through homogeneous equations. Thank you very much.